Assalamu alaikum, my dear students. How are you? Hope you will be fine and okay. Here is Muhammad Ikram, your teacher in physics. Today I will explain you the last topic of the work energy unit, that is efficiency. So let us start with the name of Allah Almighty. Bismillahir Rahmanir Rahim. Now, like work energy, efficiency is also one of the most important terms. Let me define the efficiency to you first, and then I will explain it to you. Efficiency is, in fact, we can define physically as efficiency is the ratio of, it is the ratio of output to input. This is efficiency. It is sometimes denoted by a Greek symbol like eta, right? The question is that what does really it means? What is the concept behind the efficiency? In fact, efficiency is one of the most important terms which describes the performance of a particular machine, that how much the given machine is useful in utilizing your input resources. For example, as I talked to you about the energy, and I told you that energy is one of the basic need of us. We can't do anything without energy. Even your teacher is unable to write on the board if he does not possess any energy. So energy is one of the most important aspects. Now then, you know that I talked to you about the sources of energy, because energies are hard to find, right? The energy resources are hard to discover because some of the energy resources, you know, that they are non-renewable. So once when we waste those energy, then it will be difficult for us to find more. So this is why our main focus would be to waste less of our energy resources and to use more. So this is how the machine will do. Efficiency, which is the ratio of input to output, this output is in fact what? This is the work done. It is the work done by the machine. Later on I will talk to you about the machine, few important things. And what is this input? Input is in fact work done on the machine. One simple example I will give you, just like, for example, if we consider you all as a machine, right? So then what will be the input and what will be the output? For example, your parents give you the pocket money when you go to school. So this is, and they give you some lunch also. That is your input. Now what will be, you will be using those inputs, and what will be the output from you? What do we expect? We expect learning from you, right? And now how much you learn at the school, whether it is proportional to the amount which we spend on you. This is just a kind of example, not that much a physical example, but I just want to give you the concept or the idea of the input and the output in that sense. So what the parents gets in return from you, that is in fact what? That is in fact the output. So that ratio is called efficiency. In fact, the concept of the efficiency is that how much useful the given machine is in utilizing your input resources. For example, if I have a machine, right, and if I supply the machine with some mechanical energy, and if I want to produce electrical energy from the generator, so the amount of electrical energy which the amount of mechanical energy which I supply to the generator, in return how much energy I gain from the generator in the form of electrical energy. This is, if I calculate this ratio, it will be efficiency. Now, how? That is, in fact, this is what I will tell you, that this is in fact the input energy, rather I would like to tell you. This is the energy supplied. This is what? This is the energy supplied. While this is what? This is the energy supplied by us. And this is what? The energy gained from the machine. The energy obtained. This is what? The energy which we obtain from a particular machine. That is called the efficiency. Efficiency, it is a pure number. Efficiency is what? It is a pure number. Less than 1. Less than 1. Why? Because the output, the reason for this, that output is always less than our input. The question is why. I will be telling to you this thing very soon here. The pure number, less than 1 or less than 100%. This is for all the real machines. For what? For all the real machines. So can we have machines other than real? Yes, we call those machines as the ideal machine. The ideal machines have efficiency always equal 1 or 100%. They do not waste any resources, but those machines are called ideal machine. Why? Because they don't exist. If there is a machine, some of the input resources must be wasted. Why they must be wasted? That is a bigger question, and soon I am coming to that point. At this efficiency, it has no unit. Has no unit. Why? Because it is the ratio between two similar things. So it doesn't carry any unit. The output, because it is the work done has unit joule. So joule and joule get cancelled. So this is why it has no unit. The second important point is that percentage efficiency. Percentage efficiency. This is not a proper word to write, but for simplicity I am doing. Percentage efficiency. What is percentage efficiency? For example, if you tell someone, because this is a number always less than 1, if you tell someone that my machine, the machine which I invented, is 70% efficient, then this gives more beautiful concept and approach than if you say that my machine is I have a machine, yeah, I invented a machine which has efficiency 0.7. So this does not convey any good message. So this is why efficiency is always expressed in terms of what? In terms of percentage. And that is how output, ratio of output to input, and multiply by what? And multiply by 100%. That is that is what? That is the percentage efficiency. So if machines are 35% efficient, they are 99% efficient, 80% efficient. So we most often express efficiency in terms of percentage. Why? Because this is good in concept, right? So let me explain it to you further. And now we can also express machine the efficiency in terms the best, that is rather the best than saying output. by input, that is output power by input power. If you write like this, that is the power out, we can also express this. I'll be now writing 100%. We can also express this by the way power out, that is best, that is more proper. Power out divided by power in into 100%. And power, inshallah, I will explain in the next lecture. So you see that is more practical, more close to applied physics, that the power out, power in into 100%, and that work best. So if you know your output power and if you know your input power, then you can calculate the efficiency of your machine. Now, a few important points here I would like to add to this thing. That is that the concept of the efficiency is that how much the given machine is useful in converting your input energy into useful work done with minimum energy loss. Right? Look, I do not say the zero energy loss. Why? Because it is almost impossible. Some of the energy must be wasted. So the good machine is the one which utilize maximum of your input energy resources into a useful work done. That is a good machine. Now, we should not confuse this term with the power. Power is something different. A machine may have greatest power, but it may have smallest efficiency. This is possible, and when I explain to you the power, then you will see it like that. For example, I just want to give you one simple example. All petrol engine, they have efficiency from 30 to 35%. For example, your petrol engine, they have efficiency 35% of the car. Now look, the power of the, you just read about the power of the car engine, and you just see, look, its efficiency hardly 35%. What does this mean? The output is the 35%. If I just display it into the situation like that, what does this mean? That if you supply 100% input energy resources, that input energy comes from where? For example, the chemical energy stored in fuel, that is petroleum. So for that 100 joule of energy, only 35% of energy is utilized into useful work done. What is that useful work done? The kinetic energy. Because you want to drive your car. So you get 35 joule of, for example, 35 joule of kinetic energy by using what? By using 100 joule of chemical energy. So where the rest of the energy goes? That is a bigger question. The rest of the energy goes into heat. You just touch the bonnet of your car once when you arrive at your station, and you will see, you touch the tire and you will see how hotter those tires are. Similarly, into sound, like that. So in many ways, that energies are what? Utilized. So this is how the thing is. So efficiency of the machine is a term which describes the performance of your machine, which tells you that how much your machine is efficient in utilizing your input resources while wasting very less of your input and convert more into useful work done. Now, for example, I have some few machines and you will see it now. Look, for example, how I just want to tell that how much of the input resources is being wasted and utilized. For example, I have these two machines in my hand. One is the trimmer and one is the shaver. You see. Now look, what I need from them, the mechanical energy. Why? Because I need a mowing blade so that the mowing blade can just trim the hair. Now look, as you see it, you see, look, you notice about the sound, listen to it, whether it is faint or louder. Now let us see this shaver. We need the same mechanical energy from this also. And now let us see. Listen the sound and see, is it higher pitch or low pitch? Very high pitch, a louder sound. Look. For example, if I consider the power of these both the same, let me say, look at this one and look at this one. You see, we both provide which kind of energy to the trimmer? We provide electrical energy to the trimmer. This is the input. I provide what? The electrical energy to the trimmer. Electrical energy. I provide the electrical energy to this trimmer. This is my input. The holy solely energy provided, yeah, it is powered. These two machines are powered by electrical energy. Now see, look, when I get the output from this machine, then what is that output from the machine? The output which the machine gives me is not the kinetic energy only. Kinetic energy. This is what I want. This is desired. This is wanted. Now, what other energy you see? Look, the sound energy. You got the sound. Undesirable. This is undesirable. I do not need sound right now. That is desirable. I'll write desirable as this. See here, along with the sound, there is heat energy also, which you do not feel, but I feel. When the machine are running, the blades of the machine or of the trimmer get hotter and hotter, and this is what I feel. Unfortunately, you don't have this in your hand so that you can feel it. You can only listen and see. So look, the sound energy and the heat energy. Now let us make some sort of comparison. And what is that comparison? You see, look, if we compare, then here for the same, if I provide the same energy, for example, look, if I just give 50 joule of input energy, electrical energy per second, for example, to this one and to this one, yeah, let's say, for example, this is more like 25 joule, yeah, 10 joule of energy, let's say, 10 watt machine, I say, for example, 10 joule of energy per second is supplied. So one is the trimmer and one is the shear. For the trimmer, for example, you see this produce less noise and this produce more noise. The sound produced by this is louder and by this is fainter. So that I get more kinetic energy from this, for example, 8 joule and per second. And from this, the one goes into, for example, let's say I just get 7 joule of energy from this. This is for example, from the trimmer. This is, for example, the shaver, like you see. So the 7 joule, and you see, look, in the sound, for example, 2 joule energy goes, and in the heat, 1 joule of energy goes. So you see, the law of conservation of energy is also valid. Energy is neither created nor destroyed. The total energy of the system remains the same. This was our last topic in the previous lecture. So the total energy is 10 joule. Here you see 7 joule to 9 plus 1. That is equal total 10 joule of energy. Now, but look, how much I get this 7 joule of energy. This is what I will look to this rather than looking to these two. These two are wasted. These are what? These two are wasted. I don't need, right? I need only what? I need only this. Similarly, if I supply the shaver also 10 joule of input energy, for example, if it is powered by an electrical motor with 10 watt. So you see, these are all guesses, okay? you see, I just provide 10 joule of energy per second as the input electrical energy. Then it gives me 5 joule of energy, and as look, you are hearing a louder sound, so more energy is going to sound and more to, for example, to heat. So you see how much energy you are getting. Let me place it here. Look, you see that here you are getting what? 5. And look, this is the energy which is wasted. So you have seen that maybe power might be the same, but efficiency will never be. Depends on the kind of machine. So you see, look how much energy, 5 joule of energy is wasted. So here if you just calculate the output efficiency, so look, this is 10, this is 5 by 10, and you will get what? You will get that this comes out to be 50%. So this is 50% efficient, means that it utilizes only 50% of your input resources, while that one will be 7 divided by 10 and 100, that is 70%. So the trimmer utilizes 70% of your input resources and only wastes 30% of your input resources. This is what the efficiency is. So efficiency describes that how much the machine is capable in converting your input energy into useful work done, right? So the greater this number, the greater will be the efficiency of your machine. This is what I just did for the mechanical system. Let us do it for some other thing. For example, it is not just the story of trimmer and shaver. For example, look, if we have the light bulbs, you see, yeah, look, this brush. How louder is this sound? So how much energy it is going to waste? By knowing the power, every electrical appliance usually has written the power on it. For example, if you just read from this bulb, the power is written on the bulb. Even on this, sometime this is we call a 0 watt. So in fact, this is just the kind of advertisement. No bulb has actually a 0 power. So this is usually 5 watt or 6 watt like that. So look, for example, if unfortunately right now I don't have, look, I have one this energy saver, right? You know this very well, you aware of this in Pakistan. And one you have a kind of bulb in which you can see the filament, right? That usually produce a kind of yellow light. That is called the tungsten bulb, right? That is, so you see that, look, you replaces those bulb by what? By these energy saver. Now why? Because even look, this bulb has the filament inside it. If you just see, look, there is a filament you see. So that is just similar like this, but this is small and that is a bigger. You have seen this many times. Now when you compare, look, for example, that this, the bulb, the tungsten filament bulb, they produce, if you have the bulb produces 20% light and 80% heat. And 80% what? And 80% heat. So you see, look, from the bulb we need light. Heat is undesirable to us. We don't need the heat. So what does this mean? That only 20% of your energy is going to be wasted. 20% of energy is, 20% of the energy is utilized in useful work done. That is what? Light energy. And 80% is wasted in the form of heat, which we don't need. Then the engineer invented what? The energy saver, which does not work on this principle. Now why? For example, look at this bulb. How does it happen? You provide electrical energy. Electrical energy, that is when the electron moves in a wire or when they pass through the filament, that electrical energy, now when you supply, it changes into kinetic energy. Because when the electron moves, they have a kinetic energy. As they move, they have a kinetic energy. When they pass through the filament, the kinetic energy changes into what? Light energy, unfortunately very less for the bulb, 20%. And heat, 80%. And when you touch the bulb, the cape of the bulb, you definitely feel how hot is it. Now let us see. For example, look, but if you have the energy saver, the story is different. Look, this energy saver, for example, the energy saver gives you more light. It gives you more light and less heat energy. Even you can touch it like this also, that is not hot. That gives you the energy saver story is reverse. For the if you have what? If you have the energy saver, the tube light, for example, this tube light. What does the tube light gives? They gives you 20%, produce 20% heat and 80% light. This is why in my this room there is all tube lights only. There is no bulb, the tungsten filament bulb, the incandescent light, right? So that why? Because it only wastes less. 20% goes into heat and 80% goes into what? And 80% goes into light. So that is all about what? That is all about the efficiency of this. Second important point here is look, for example, dam. If you just see, look, if you have the dam, how the engineer calculate the energy loss. Because for example, the energy stored in a dam, let us suppose for example, if we have a Tarbela dam like this, right? We have this a kind of dam filled with water. The project head, this is all, for example, look. Till here, you have here the water channel, that is like this. For example, the water has to flow through this channel. For let's see, okay. And here is what you see. Here is the turbine. There is turbine, like a rotating blade like this, a kind of turbine. The turbine is then connected with what? That turbine is used to turn what? The turbine is attached to generator. There is a kind of generator, for example. It rotates generator. Now you just see the energy losses here also. For example, what is the total energy with you? The total energy with you is, look, from here to here. This is the height. The water has to fall from this height. So what is the total potential energy? That is mgh. Now look, that is the maximum available energy with you. Now the engineer consider all the factors to utilize more input resources into a useful work done. Here you want to generate what? Electricity. To the full input supplied, unfortunately it is impossible. Why? Because as when the water flows through the channel along this path, what is going to happen? You see there is force of friction. So some energy is wasted into heat. You hear the sound of the waterfall also. Some energies goes into heat, into sound, and even some of the water particles or some of the water might not arrive exactly onto the blades of this turbine and they will miss it. So some goes, that is, some, even the water is wasted. Some of the water will not arrive on the blades or of the water. So look, this is wasted, this is wasted, this is wasted. So do you expect this is your input and this is your what? This is your output. Electricity is your output. So can you expect that you will get the same again? Certainly not. Right? Why? Because this is no more available to us. This energy is not available to us. This is not available to us. This is not available to us. So therefore, output is always less than what? The input. This is why the engineer calculated sometime the power losses also, right? It also depends on the kind of the machine you are using, right? The turbine you install. So there some of the energy, look, they will also waste some energy in friction, right? In sound, in heat even. So here is also wastage. Heat, sound are like other form of energies. So complete silent machine is impossible. So you always get less energy. So we say that the efficiency of the generator is this, and that is always smaller than 1. Now, as I told to you that I will talk to you about the machine also. There are some misconceptions about the machine, and I just want to address those misconceptions also. Right? See here. If you have a machine, this is what I write, any kind of machine. From simple machines, simple is just like, for example, a silver, to a complex machine like a car, aeroplane, even trimmer, electrical machines. They have something common, or there are some facts about those machines. First of all, you must remember that the first fact about the machine is that it makes our work easier, makes the work, a machine can make the work easier. Bas. Easier means it can do it faster if it has a greater power. It can be used to transfer force. Right? To perform the work faster or to transfer force from one point to another point. This is the job of the machine. But remember, class, that machine does not have source of energy. Remember, it does not have source of energy. This is very important point, right? No machine has the sources of energy. If you say that machine can create energy for you, you are wrong, right? If this happens, the physics books will be rewritten. You just think, what are you saying? It is not acceptable, right? You can say your machine can be 99% efficient, but you cannot say that you have invented a machine which has sources of energy located in it. Machine has no sources of energy inside it. The second important point is that you don't have these things about machine. The second important point, cannot store energy. Store energy. Machine will never store energy for you. Is it clear to you? Machine what? Never store energy. And last but not the least, that machine cannot increase or decrease the amount of work. Means cannot increase what? Increase or decrease the amount of work. The amount of work. For the explanation of this point, watch my lecture on power. Inshallah, you will see why a machine cannot increase or decrease the amount of work. So these are the 4 facts about any machine. That machine will make our work easier. in by doing it faster or by transferring force from one place to another. But machine cannot have these things. No matter if your machine has power in megawatt, and no matter if your machine is 99.9% efficient, it cannot do this. It has no sources of energy located in it. It cannot store energy, and it cannot increase or decrease the amount of work. If it were to be the case, then in every houses there would be now energy factories. They would invent a machine which would store energy for them, or which would have energy resources for them, or which would increase or decrease the amount of work. Since these things will violate the laws of physics, the laws of science, right? So no machine is invented yet now which have all these things. Not even a single, not all, even a single does not exist in the machine. So thank you very much for being with me, and this is my lecture about the efficiency. Today you have learned about efficiency, that efficiency is a useful term which describes the performance of machine by telling us that how much the machine is useful to convert input resources into the output, right? That how much energy it can convert from input sources to a useful work done. So efficiency, don't say efficiency and power the same. They are completely different, and inshallah you will see that in the next lecture. As I told you, a machine may be more powerful, but it might be less efficient. And I give you the example of the car engine, that it has a greater power, but still it is 35% efficient, right? So the engineer tries to work out the efficiency of the various engine, and they they increase the energy of the they increase the efficiency of the machines by working on the energy loss, to minimize the energy loss, right? So thank you very much. Inshallah, see you in the next lecture. Allah Hafiz. Goodbye.